Let's take a look at problem number 5. Table below describes the smoking habits of a group of asthma sufferers. We have a group of non-smokers, occasional, regular, and heavy smokers, and then that gets broken up to men and women. So the first thing to do probably for these types of things, if it's not already given to you, is to set up extend your table to get the row and column totals. So the row totals, I added the rows up here, 571 and 566. And then if I were to add these two things, I should get, let's see, 571 plus 566 is 1137. Now I want to get the column totals here. So column totals are going to be, for the first one, 424 plus 360. For the second one is 39 plus 85. 72 plus 77. And let me write this down before I lose it. 784, 124, 149, and then the last one is going to be 36 plus 44, which is 80. Just to make sure, and it's always good to double check, you can add the bottom row, the row totals, and make sure that you get 1137. So I'll do that real quick. 784 plus 124 plus 149 plus 80, and I do get, in fact, the column total that we had hoped for. So here is our column total. Alright, let's see if we can answer these questions, and let's use the appropriate notation for these things as well. One person randomly selected from the group, find the probability that the person is a man or a heavy smoker. So the probability that this person is a man or this person is a heavy smoker. So here's our notation. This is another OR statement, so we're going to use the addition rule. Heavy smoker. And then we're going to subtract out the possibility that this person is a man and a heavy smoker, because we don't want to count that twice. So the probability this person is a man is 571 out of 1137. And then we want to add the probability that this person is a heavy smoker, which is a probability of 80 out of the total. And then we want to make sure we don't count them twice. So there's 36 men who are heavy smokers, so that's 36. So that would be 36 out of 1137. That gives us a grand total of, if I just add the numerators, 571 plus 80 and then subtract out a 36. That's 615. And to get the decimal or percentage out of that, you divide by 1137. So 615 divided by 1137, which is equal to 0.5408, rounded up, would be going up to 0.09. So here's our answer. Alright, let's go to the next one. Probably the person is getting somebody who's a regular or a heavy smoker. So how's that probably going to look like? Let's see, probably that we get a regular smoker or a heavy smoker would look something like this for starters. And then we're going to use again the addition rule. That's the probability that we get a regular smoker plus the probability that we get a heavy smoker, and then we would subtract out the probability that we get a regular smoker and a heavy smoker. Now this is slightly different from the one above because the probability that we get a man or a heavy smoker is 36. That's where the men row and the heavy smoker column intersect. But if we look at the probability that we select a heavy smoker or a regular smoker, these things don't have anything in common, so they don't intersect. So really this is 0. It's not going to be important for us. I'll leave it there though. Probably we get a regular smoker is 149 out of 1137. We add the probability that we get a heavy smoker, that's 80 out of 1137. And so, and then just to be clear, the probability that we get a regular smoker and a heavy smoker is 0. So we're really just adding 1149 plus, I'm sorry, let's call that 149 plus 80. So that's 229, and then we divide by 1137. So 229 divided by 1137, which is about 20.14%, 0.212014 would be your answer for this one. Alright, so that takes care of the second one. Third one, if a heavy smoker was selected, find the probability that this person is a woman. So we're only restricting ourselves to the heavy smoker selection. And there are 44 of them are women. So what we really have here is what is the probability, what's the probability that we select a woman given that we're just selecting from the heavy smoker bunch. So there's several ways to do this given the table. That one here we can find the probability that we can do the selection here, but here we can restrict ourselves to just out of 80. This is 44 out of 80. And then this is going to give us, it should give us a result, which is about 55%. Now another way to do this is if we want to find out this probability, there's a formula similar to this that had something about a probability that we select a woman and a heavy smoker, and then we divide it by the probability that we select a heavy smoker. Now this is just another way to do this. It's going to require more steps than what we had done in the previous option, but just to show you that these are both correct, we look at the probability that we select a woman and a heavy smoker, and so this is just selecting from the whole population. This would be a 44 out of 1137, and then we want to divide out. Let's put parentheses here just to be absolutely clear. And then we want to divide out the probability that we get a heavy smoker out of our group. So that would be 80 divided by 1137. Again, some parentheses around here. So if you can do your algebra arithmetic quickly in your head, you'll see this is 44 out of 80, but just to make sure, let's punch it in our calculators. 44 divided by 1137. And let's put that in parentheses and then divide out 80 divided by 1137. And we'll see that we get the same result. And that's 55% again. So either way you do it, should work out. And again, I prefer the first way because it was a lot easier, but you have to know that you're selecting from the heavy smoker pot, so that's the 80 out of 1137 pot. Okay, now let's take a look at our last one. Two different people are randomly selected. Find the probability of getting someone who's two non-smoking women. I suppose this should have been said. This should have been find the probability of getting two non-smoking women. Now, if we're picking two different people here, we have to assume that we're picking a person and not replacing that person. So this would be an exercise in the multiplication rule without replacement, because you're selecting two different women. So that one would be the probability. Let's write it out in words first. Selecting two women, and let's say that's probability of getting a woman times the probability of getting a woman, provided that we have already selected a woman, and without replacement, that's going to make a difference here. So with replacement, P of W slash W is the same thing as P of W, but with replacement it's going to be the same. So what's the probability of selecting a woman? There's 566 of them out of 1137. And now what's the probability of selecting a woman if one had already been selected out? So there's one less woman there. Whoops. There's one less woman, so there's going to be 565 choices now, and one less person that we got. So that's 1136. Alright, just a matter of punching into the calculator. Let's make sure that we do this correctly. So 5, let's start over here. So it's 566 divided by 1137, close parentheses, and then times 565 divided by 1136, one less. And then we got 24.75% approximately, or 2475, let's call it 76 rounded off for our result. So if we make a note here saying with replacement or without replacement, it should clear things up for us. Alright, so this would be probabilities using tables.